When you have a trained model, you want to be able to use it where needed, whether you want to use it for real-time or batch inferencing. By the way, you'll also sometimes see inferencing referred to as scoring. Let's pause for a moment and analyze the difference between real-time and batch inferencing. With real-time inferencing, you want to make inferences for each new row of data, usually in real time. For this, packaging your model as a web service is the desired approach. However, other packaging options exist as well, like deployments to an IoT device. With batch inferencing, you want to make inference on multiple rows of data, named batches. For this, you can use any compute resource that supports any environment enabling you to load and use your training model. Keep in mind, resources required for batch scoring can sometimes be significant. Azure Machine Learning has a dedicated type of compute resource for real-time inferencing called inferencing clusters. After you've trained your model and you're ready to use it, you can deploy it to either a web service or put it on a machine, such as an IoT device. When you use your model, it infers things about the new data it is given based on its training. So what kind of compute can be used for inferencing? First, there's the inferencing cluster for real-time inferencing. Then, virtually any compute resource can be used for batch inferencing. However, once you're prepared for production, you typically will take the same model and want to deploy it to an environment that can host your model. For real-time inferencing, you might choose one of the cluster options, like Azure Kubernetes Service. This option provides fast response times and auto-scaling for deployed service. Azure Machine Learning Training Clusters allows you to run batch inferencing. Azure Machine Learning enables you to package your trained model in a container, which enables you to use it in a wide range of destinations for deployment. Some examples include Azure Functions, Azure IoT Edge, and Azure DataBox Edge. These options allow you to use your trained models in a variety of environments. For example, you can deploy your model to an intelligent video camera where it can be used to perform real-time inferencing. Let's walk through a high-level architecture of a possible deployment. Starting on the left, there is a web app users visit to make predictions with the deployed machine learning models. The models are deployed as a container instance in an Azure Kubernetes Service cluster for high scalability. Azure Machine Learning was used to train these models, register them as scoring web service Docker images in the Azure Container Registry, then deploy the images to designated inferencing clusters. The models are stored within Azure Container Registry, which is a service that hosts Docker images for managed image deployments to containers. As you can see in this diagram, the web app invokes the AI model trained in Azure Machine Learning solely through the deployed web service.